Alright, so in this video we're going to create Hangman. This one we're just going to kind of focus on the logic, just get things working, and then we'll take another video to go back and see how we can refactor it. So let's start with a Hangman directory, and I'm going to split these windows just a couple times so you can write code in one window, run it in another, and kind of play around the IRB in the other. So let's have Hangman RB open. So we got a new file. Open up a Hangman class. So in Hangman we have a word that the user doesn't know. We display them just a bunch of spaces, stars, or whatever else, and they have to guess one letter at a time to try and uncover what that word is. So let's just start with a hard-coded word for now. And we'll also want to keep track of the progress that the user makes, which will start off as just a bunch of stars for as long as the word is. And that, we can do because Ruby lets us do some math operators on strings. So we just multiply this star as long as the word. And let's see, so we'll need a game loop. We'll have to ask the user for input, come back, check against the word, ask the user for input again, back and forth until there's some end game condition. So let's get a guess from the user. We'll use chomp and gets. So gets lets us prompt the user for some information. The problem with gets is that it comes back here with a new line at the end of it. So what we want to do is take that and we'll chomp, and I'll get rid of that new line character. So we get the guess, and if the word has that guess, then what we want to do is update progress with the letter that they've guessed where it belongs, according to where it is in the word. So one way to do that is to take the word, split it up by its letters, where you can see we do split by empty string, we get all the letters, and we can loop over that with an index. And the reason we want to do that is so that let's say the user guesses n, then we'll come into the word and we'll say, okay, at the 0th position, what is that letter? Is it n? No, it's not. Okay, continue on. Okay, position 1, what are you? Are you an n? Oh, yes you are. So now I want to take progress at the same position 1, and I want to change the star to an n. So when we find that the letter inside of the word is equal to the guess, we will say take progress at that same index position and make it that letter. And we'll also add a when condition here, right? So if the word is exactly the progress, that means the user's uncovered the whole word. And we'll say UN, and then we'll return just to get out of the while loop. So let's start our game, we'll play. Oh, and just so that we can actually see what's going on, we'll put, say, progress is progress. Right, and this syntax is just string interpolation. So if you have some string and we have some variable foo, which is also a string or whatever else, maybe a number, then we can take a string and we can take that value. If we wrap it in a hash curly braces, it'll just put that value in here and actually say, you know what, let's make this something more obvious. Right, put the value of that inside the string. So now we print out the progress, we get the user input, we compare it. Let's see how this goes. Okay, Q, nothing, A, N, M, O, P, I. Cool. So we can guess letters, we have a win condition, great. Now something should happen when you guess wrong. All right, and so if you don't guess correctly, then we want to say, I guess we want to actually limit the number of times you can guess incorrectly. All right, I'm just going to say 6 to start with. And we'll say every time you guess something wrong, subtract a guess. And if guess is 0, then you lose. And we'll return out the loop again. Okay, let's try it out. Q. Okay, so it worked, but that was kind of not obvious. So let's print out how many guesses do you have left. Oops. Guesses. Okay, and if I guess a correct letter, it stays the same. Okay, so that's really the bulk of what Hangman is. There are some weird cases that we can handle, like I can guess the same thing over and over again. You know, maybe that's something we want to prevent the user from doing. So we could store up like previous guesses, and if previous guesses includes the current guess, then we say you already guessed that, and we'll not return. We'll actually do next, which what next does is it says, okay, I've hit this point. You can stop going through this iteration of the loop and just start over again. So we'll come in here, see that they've already guessed something, say next, and it'll just start right back over at the top of the loop. And then we can get a new guess from the user. And so if they haven't already guessed it, we want to populate previous guesses with their current guess. Oh, and one more thing we'll probably want to do is print that out just so we can see. So I haven't guessed anything. I've guessed A, I, O. I've guessed some wrong things. I know not to guess those again. Cool. So another case we could handle is, oh, you know what? I've already guessed that, so yeah. We don't have to worry about anything showing up more than once. Cool. Let's see. What about this? Yes. So that seems odd. You shouldn't be able to guess things that are more than one letter. So let's put another clause in here for if guess.length is not equal to 1, then guess this must be 1 letter long. Must be, I don't know, exactly 1 letter. And then we'll go through the loop again. We won't subtract for a weird guess like that. So kill this, try again, and cool. So about this. So this is another case we could handle. We have to do a little bit more validation. All right, so we want to check if something is a letter. So to do that, we could use, and I think I will use regex. It's a simple regex, so I'm not too concerned about it. Alphabetical. It's really just through Z and A through capital Z. You know what? Even before that case, we actually haven't handled capital letters. So let's do that one first, actually. So if I run this and I say capital O, yeah, fails. So let's actually fix that one first. So let's see. When we do the check, if the word includes it, we can actually just say dot lower? No, downcase. I believe is the correct method call. Yes. So we'll take our guess, downcase it, and then match it against the word. Right now we're kind of assuming onomatopoeia is all lowercase, and it is static right now. I guess we could say the word, this is the word. We can pass this in here. So let's make it kind of funky so that here we can just always store it as lowercase. So we know for sure. So guess, and actually, you know what, just right the moment we take this, let's just downcase it. Let's not worry about figuring out where all the way down here we need to downcase it. So we're always dealing with lowercase letters. Okay, let's go over here. We start this up again. So O, capital P, E, I, A, and T. Cool. All right, so now back to numbers. Dealing with numbers. So get an alphabetical regex, which to create a regex, you just have 2 forward slashes, and the regex is as simple as if it's between A and Z, or it's between A and capital A and capital Z. So if you are the wrong length, or if the alphabetical regex does not match your guess, then we go into this logic here. We've got some errors down here. Output. Let's see, I'm missing something. Oh, oops. Don't need this if here. There we go. And let's try running it again. So guess numbers. It's fine. Z's, X's, multi-letters. And let's see a lose condition. Yep. Yeah, and I think that's about it for Hangman. So I guess next version we'll kind of take this code and we'll refactor it a bit to be a little bit easier to work with. Some of the problems you can kind of see, like this isn't an entire loop, all the logic lives in here. This is impossible to unit test because you'd have to sit here and work with the game loop. There's kind of a lot of responsibilities living in this Hangman class, right? There's display logic, there's user input, interaction logic, then there's along with how does the game actually work and some of the real game logic. So the next one will kind of show how to refactor some of that out.